All right, in this video, we're going to talk about polynomial operations and factoring cubic expressions. So a polynomial in one variable has the general form that you're seeing, a sub n times x to the n plus a sub n minus 1 times x to the n minus 1, etc., all the way down to a sub 0. So I'm going to write out a example of a polynomial expression, and then we're going to get into some of the vocab that you're seeing. We'll do plus 2x squared plus 5. Cool. So this is an example of a polynomial expression. So we have my leading coefficient. My leading coefficient is the coefficient of the term that has the largest exponent, which we call the degree. So how this works, the 8 in this case is the example of what's called the leading coefficient. The 6 is the degree of the polynomial, and then the entire term, 8x to the 6th, is going to be my leading term. So just to kind of show that there, that would be my leading term. And n again is the degree of the polynomial. So the largest exponent you have, that is the degree. So we would say that this is a 6-degree polynomial. So when we add and subtract, adding and subtracting is combining like terms. And when we multiply, we're going to be distributing each term of one polynomial to the other. All right, so first we're going to find the sum of these two polynomials and then state the degree and the leading coefficient of the resulting expression. So if I were to add these two polynomials together, again, it is combining like terms. So I have 8x cubed minus 2x squared plus 6x minus 2. And I am adding the polynomial 3x to the 4th minus 2x cubed plus x squared plus x. I put that in parentheses just to show which polynomial expression is the second one. But we know that because it's positive, then we're adding it, that there's not going to be any sign changes to that. So now I'm just going to go and I'm going to combine my like terms. So I see that I have 8x cubed and negative 2x cubed. I have negative 2x squared and positive x squared, and I have 6x and positive x. So when I go and I combine all of those, I have my first term, I have 3x to the 4th, and then 8x cubed minus 2x cubed is going to get me positive 6x cubed. Negative 2x squared plus x squared is minus x squared. 6x plus x is 7x, and then I have minus 2. We write it in this order called descending order, and that's where we write all of our terms in order based off of the exponents, starting with our largest, again, the degree of the polynomial, and then we go in descending order down. So again, to find the degree and leading coefficient, I look at my leading term, which in this case is 3x to the 4th, and the degree of this polynomial is 4, and the leading coefficient here is 3. So that is how we add polynomials. So finding the difference, subtracting is not any different. The only thing is, again, we're now subtracting. So we have to worry about distributing this negative to each term of whatever polynomial expression is being subtracted. So when I distribute that negative, I get 3x to the 4th minus 4x cubed plus 6x squared minus 1 minus 2x to the 4th plus 8x squared plus 6x minus 5, distributing that out. And now I want to combine my like terms. So I have 3x to the 4th and negative 2x to the 4th. I have 6x squared and 8x squared, and I have negative 1 and negative 5. So putting these in descending order, 3x to the 4th minus 2x to the 4th is x to the 4th, minus my 4x cubed. 6x squared and 8x squared gets me 14x squared, plus 6x, and then negative 1 minus 5 is negative 6. So I just found the difference between those polynomials, and now looking at my leading term, I see that the degree of the polynomial expression is 4, and that the leading coefficient is 1, because we know there's always an unwritten 1. So that's how we subtract products, so coming to multiply. So we've been multiplying polynomials quite a bit this year. Again, this is foiling, but if you have beyond binomials, this is how you do it. Each term of the first polynomial needs to be distributed to the entire second polynomial. So I have 2x squared, and I'm going to multiply that by the entire polynomial x squared minus x plus 2. So I've now taken this and I've multiplied it to this entire polynomial. I now need to do the same thing with 5x and multiply it to the entire polynomial. So this is going to be plus 5x times x squared minus x plus 2. And then I'm going to do the same thing with my last term, negative 4. I'm going to multiply the entire second polynomial by that. So negative 4 times x squared minus x plus 2. And now there's just a lot of multiplying and combining like terms. So distributing that 2x squared gets me 2x to the 4th minus 2x cubed plus 4x squared. So this is taking care of that first. All right, on to the next one. 5x times x squared is 5x cubed. 5x times negative x minus 5x squared. And then plus 10x. So that is taking care of that second multiplication and distribution. And then for my last one, I have negative 4x squared plus 4x minus 8. So that is taking care of that final distribution. And now I look after I have all this multiplication, and I'm just combining my like terms. So I have negative 2x cubed, 5x cubed, positive 4x squared, negative 5x squared, negative 4x squared, 10x, and 4x. And that's what I'm able to combine. So now combining all my like terms, I have 2x to the 4th, negative 2x cubed, plus 5x cubed gets me plus 3x cubed, 4x squared minus 4x squared cancel out. So that leaves me negative 5x squared. 10x plus 4x is 14x, and then minus 8 at the end. So that is how we multiply two polynomials together. And again, talking about the degree and the leading coefficient, I look at my leading term. So the degree of this polynomial is 4, and the leading coefficient is 2. So that is how we multiply polynomials. So now we're going to get to factoring cubics. So like special quadratics, we had perfect square trinomials. We had the sum and difference of two squares. Or we didn't have the sum, we had the difference. So there are special cases to factor cubic expressions. So the first is perfect cubes, so a plus b quantity cubed and a minus b quantity cubed. So a trick to kind of remember this formula, because I know it can look a little overwhelming. If you're noticing, there's some patterns. So I start with my first term, a cubed, and I keep taking away an a. So it goes down to a squared, then a, then no a, as my b rises. So no b, then 1b, 2b's, 3b's. And in terms of the coefficients, 1, 3, 3, 1 is the pattern. And that doesn't change between if it's a plus b cubed or a minus b cubed. So there's a little trick to remember the signs of, in terms of, is it a plus or is it a minus? So the trick that I like to say is SAPs. So what I mean by SAPs, if I'm looking at a plus b cubed, I have a cubed plus 3a squared b plus 3ab squared plus b cubed. So looking at the signs, the first sign in the formula is always the same as the sign of what's happening. So if I have a plus b cubed, the first sign is plus. If I have a minus, the first sign is minus. The second one is always positive. So if we take a look at the second sign, again, there is no difference between them. They're always going to be positive. And then my last one is also always going to be the same as whatever it is, whether it be a plus b cubed or a minus b cubed. Because again, you're seeing there's no difference in the formulas. The only thing that's different is the signs. When it comes to the sum and difference of two cubes, again, the formulas in terms of the order is not different. What's different is the signs. So a cubed minus b cubed or a cubed plus b cubed, we have these formulas. So trick to remember this is SOAP. So the first sign is always going to be the same, whether that be addition or subtraction. Again, that's matching. The second sign is going to be opposite. So if it's a cubed minus b cubed, the second sign is plus. If it's minus, then it's plus. Minus is minus. And then the last term, AP, is always positive. So I have plus b squared no matter what at the end. And again, these are the formulas that we're going to be working with now. So finding each product, so I have 3m plus 4n quantity cubed. So this is working with perfect cubes. So my formula again is there. My a value is 3m and my b value is 4n. So all that you do is plug these into the formula. So plugging into the a plus b cubed formula, I have my a is 3m. So I have 3m quantity cubed plus 3 times 3m quantity squared times b is 4n plus 3 times a 3m times b squared, which is 4n quantity squared, plus b cubed, 4n cubed. So again, I know it looks a little daunting at first, but all that I'm doing is plugging in my a and my b value. And something that's important that confuses some people is that all of this multiplication that's happening in my middle two terms. It's important to remember that these are all one term. So you have to do all of the multiplication with what's been highlighted. And now we just simplify using the exponent properties that we already talked about. So 3m quantity cubed is 27m cubed plus 3 times 3m squared is 9m squared times 4n plus 3 times 3m 4n squared is 16n squared plus 4n cubed is going to give me 64n cubed. And again, just kind of keeping this together, I do have to do this one more multiplication with both of my middle terms. So when I multiply all this out, I get 27m cubed plus 3 times 9m squared times 4m gets me 108 m squared n plus 3 times 3m times 16n gets me 144 mn squared plus 64n cubed. And there's nothing to combine because I have no like terms, so this is this fully multiplied out. For the next one, it's not any different. Now we're just working with a minus b quantity cubed. So my a value here is negative 2a. My b value is 5b. B is not negative 5b because the general formula is a minus b quantity cubed. So again, I'm just going to now plug this in to my now second formula, which is right here. So my a value, so I have negative 2a quantity cubed minus 3 times negative 2a quantity squared times 5b plus 3 times a, negative 2a times 5b squared minus 5b quantity cubed. Again, I have these two middle terms, so I'm going to have to watch with the multiplication on that and applying the exponent rules. So negative 2a cubed is negative 8a cubed minus 3, negative 2a squared is positive 4a squared times 5b, plus 3 times negative 2a, 5b squared is 25b squared, minus 5b quantity cubed is 125b cubed. Again, the last thing we need to do is make sure that this multiplication is good. So doing that, I get negative 8a cubed. And then multiplying all of this together, I get minus 60 a squared b minus 150 ab squared minus 125 b cubed. And that is that fully multiplied out. All right, so that is working with the perfect cubes. So now we're going to work with factoring using the sum and difference formulas of two cubes. So if I have my first one, u cubed plus 8, if I take the cube root of these two values, I want to check and see if I get perfect cubes, which I do. So if I take the cube root of u cubed, I know that this is u. And if I take the cube root of 8, I know that I get the value 2. So this is the a cubed plus b cubed. So we're going to be working with that formula, which is at the top of your sheet. So reminder, just going to write this down so we have it. A cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. So now I'm just going to plug in. In this case, my a value is u and my b value is 2. So I'm going to go ahead and plug those in. So this gets me u plus 2 times u squared minus 2u plus 4. And I look the quadratic term afterwards. I see if I can factor that, and I cannot. So that is that fully factored.